Hello everyone. Now let me talk about question 2 for homework 2. In this question, the signal passes many noisy channels and it may change in some certain probabilities. For problem A, we can consider two situations. The transmitter sends 1 or the transmitter sends 0. So the answer is certain. 0.7 times 0.8 plus 0.4 times 0.2, and the final answer is 0.64. In the next part, we can try to use another method to show it clearly. The final situation is the initial situation times the probability. The probability should times twice because this is x3 and two noisy channels are passed. We get this part, and the final answer is this. So this is what we want, the probability of x3 equals 1. For this, we want to know that when the x1 equals 0 and x3 equals 1, for this, there are two situations, x1, x2, x3. This is 0 and this is 1. This or this. So x1 equals 0 and x3 equals 1. This probability is this and this. Then it is this times 0 to 1 times 1 to 1 plus this initial situation times 0 to 0 plus 0 to 1 and the probability of x3 equals 1 is calculated in the B part. So the answer is about 0.176. The D part. We use the similar method in B to represent the whole situation. When n is close to infinity, the probability is actually the initial part times the probability. and the probability is n squared, has a power of n. When the system is stable, the final situation does not change when it times this probability. So we want to know this part, so we assume that the final situation of xn equals 0 is a. Then the probability of xn equals 1 should be 1 minus a. And finally, it will satisfy the equation of this times this equals a 1 minus a, which means that it does not change when n changes. So this situation should satisfy the equation of this plus this equals a. This plus this equals 1 minus a. These two equations are actually the same. After solving them, we can know that a equals 3/7. That is, the final result should be the 3/7. That's all for problem 2.